Let's take a look at this question now. The continuous random variable x has probability density function f given by this. Find the distribution function. Distribution function means that we're actually finding out cumulative distribution function, which means that in order to find it, I have to integrate f of x. So if I want to go from density to distribution, I do integral, and backwards I have to do differentiation. So the way we write this is that this is f of x. For distribution function, I write down capital F of x, or cumulative distribution function. All right. So I have to integrate this with respect to x, and I need to have also a plus c at the end. So f of x for 4 to 16 equals to 1 by 80 times this is 3x to the power half minus 8x to the power minus half. So here we have 3x to the power 3 by 3 by 2 minus 8x to the power half by half plus c. So we have here 1 by 80. This is supposed to be 3 gets cancelled. So we have a 2 root x cube minus 16 root x plus c. Now, because this is a cumulative distribution function, we can do two things. One or two things. We can either do f of 4 equal to 0, the minimum value, because we have added nothing yet, which means that there is no probability. So we have f of 4 equal to 0. Or if you want to deal with it more easily, or something easier to understand is f of 16 equals to 1. Because at f of 16, we add all the probabilities together, including the one at f of 16, and the sum of all of them together gives me 1. So which is why I have 1 by 80, 2 root 16 minus 16 cube minus 16 root 16 plus c equals to 1. From here, I just need to find out the value of c. 1 minus 1 by 80, 2 root 16 cubes minus 16 root 16. We get 1 by 5. Therefore, what we have here is f of x equals to, the way we write this is that we write it like this. We have, at first we write down 0 for anything less than 4. And then we have 1 by 80, 2 root x cube minus 16 root x for x between 4 and 16, and 1 for anything greater than 16. If you write down this much, you will get your mark. That's the technique behind this. And in part 2, what we have is probability density function of y. So we have a completely different function in terms of x. I need to find the distribution of density function of that. So the trick is that we know we want to find density function, right? What we have here is f of x equals to probability of x less than x. This is the way we write things down here. Because we have here something of y, which means that the distribution function of y is going to be completely different. Not the same as this one, so it's going to be a completely different function. So we actually have g of y equals to probability of y less than or equal to y. So g of y equals to probability of y equals to root x less than or equal to y, or this means that probability of x greater than less than or equal to y squared. What it means is that I can replace anything inside this one, any x inside with y squared. The way we write this is like this. 1 by 80, 2 into we have here y squared to the power 3 by 2 minus 16 y. Oh wait, I forgot to 1 by 5 there. Plus 1 by 5. This is supposed to be my g of y. So then what we have is 1 by 80, 2y cubed minus 16y plus 1 by 5 equals to g of y. And because I have to find a density function, I need to differentiate this one. So g of y equals to 1 by 80, 6y squared minus 16. y cube, 6y squared minus 16. I think this is supposed to be 8. Yeah, I think it's supposed to be 8. So they could also take out 1 by 14. I was just looking at the mark scheme. They actually took 2 common out of it and they got into similar form. But I don't need to do that. I can leave it like this here. But it's not the final answer because I need to represent it for the entirety of the possible case scenarios of x. So I write it down like this. 1 by 80 of 6y squared minus 16 from 4 to 6 and 0 for otherwise, which means that it would not be valid usually for anything outside of this little range right here. But that's my answer. And that's it for this question.